Here we have a SAT math question. Okay, let's go to the question. The perimeter of an equilateral triangle is 624 centimeters. The height of this triangle is k times square root of 3 centimeters, where k is a constant. What is the value of k? Okay, first let me draw an equilateral triangle. Here I have drawn an equilateral triangle. Let me name the vertices. Let me assume this is vertex A and this is vertex B and this is vertex C. Okay, since this is an equilateral triangle, the length of each side must be same. So I assume the length of the side BC is x, then the length of side AC also must be x, then AB also must be x. Because it's an equilateral triangle, all the sides must be having equal length. Okay, so to get the perimeter of this equilateral triangle, what should I do? I just need to add the length of all the three sides. That is x, positive x, positive x. So here I have added the lengths of all the three sides. So this expression represents perimeter, but already the perimeter is given in the question, that is 624. So since this expression represents a perimeter, it can be equated to the perimeter given in the question, that is 624. Okay, now we can solve for x in this equation. So when I add so x and x, I'm getting 3x. 3x equals to 624. Okay, now what I'm going to do is I have to divide both sides by 3 to solve for x. When I do so, this 3 will cancel out. I'm getting x equals to 208. So I got the value of x, that is x equals to 8. Actually, x represents the length of each side of the triangle. So we can replace the x for each side by 208. So the length of each side of the equilateral triangle is 208. Okay, now what I'm going to do is I'm going to draw altitude for this triangle. I mean, altitude means a height for this triangle. So to draw altitude or height for a triangle, we have to draw a line segment from one of the vertices to the opposite side. Okay, I'm going to draw height for this triangle from the vertex A to the opposite side BC. Okay, so whenever we draw altitude or height for a triangle, so it will be perpendicular to the side over here, because here we have drawn the height for this triangle from the vertex A to the side BC. So the height will always be perpendicular to the side BC. And also, since it's an equilateral triangle, so the height we have drawn over here will bisect the side BC. Okay, let's name at the point where the height intersects the side BC as M. Okay, now since it's an equilateral triangle, whenever we draw altitude or height for an equilateral triangle, so the height will bisect the side over here. So that means it will divide the length of this side BC into two equal parts. Already we know that the length of the side BC is 208. So then the length of this segment is 104 and the length of this segment is 104. And also the height of the triangle is given in the question itself, that is k times square root of 3. Okay, let me mark it, k times square root of 3. This is the height of the triangle. Okay, and also in an equilateral triangle, when I draw altitude or height, so what it will do is it will bisect the angle over here. And also, since it's an equilateral triangle, each interior angle will measure 60 degrees. So this is 60 degree and this is 60 degree and this one also 60 degree, but this 60 degree will be bisected, that is it will be divided into two equal parts by the height. So that means the angle measure over here will be 30 degree and the angle measure over here will be 30 degree. Okay, now ACM, consider the right triangle ACM. So it's clearly a 30, 60, 90 special right triangle, because here we have 30 degree and here we have 60 degree and this is a right angle 90 degree. So in a 30, 60, 90 special right triangle, the shortest leg is the one which is opposite to the smallest angle, that is 30 degree. So here MC is the side which is opposite to the smallest angle, 30 degree. So MC is the shortest leg. And what is the next longer leg? The next longer leg is the side which is opposite to the 60 degree angle measure, because this is the next larger angle. So this is the side, AM is the side which is AM is the next longer leg. So because it is opposite to 60 degree. Okay, so how do we have to get the length of AM? I mean the height. So in a special right triangle, whatever length we have for the shortest leg, which is opposite to 30 degree, then the length of the side which is opposite to 60 degree will be square root of 3 times the length of the shortest leg. So then the length of AM has to be 104 times square root of 3. So whenever I want to get the length of the side which is opposite to 60 degree in a special right triangle 30, 60, 90, I just have to multiply the length of the shortest leg. Shortest leg means which is opposite to 30 degree. I have to multiply the length of the shortest leg by square root of 3. So that gives the length of the side which is opposite to 60 degree. And also we can check for the hypotenuse, but already we know the length of the hypotenuse. According to the concept of special right triangle 30, 60, 90. So to get the hypotenuse, we have to multiply the length of the shortest leg by 2. When I multiply this leg, this 104 by 2, I'm getting 208. So it's exactly there already. Okay, now I got the height of the triangle AM, that is 104 times square root of 3. But the question says height of the triangle is K times square root of 3. At the place of K, what do we have? We have 104. So the value of K is 104.